Good morning, students. I'm Dr. Vijay Bhandari, Associate Professor in CSE Department. Let's start today's topic, thread in Python. So, I will introduce first what is the definition of a thread and how it works. So, a thread is a separate flow of executions. Python threading allows you to have different parts of your program run concurrently and can simplify your design. If you have got some experience in Python and want to speed up your program using threads, so this session will be helping you more, right? And before the session, we have seen how regex works, how the what is the data structure in Python, right? So we have covered a lot of things, a lot of data types, the tuples. So hopefully you are understanding data structure, how it works, right? What are the operations we perform here, right? So in this session, we will see what is the thread, how to create threads and wait for them to finish, how to use a thread tool executor, how to avoid race conditions, how to use the common tools that Python threading provides. So this session assumes you have got the Python basics, right? Download paths, and you are using at latest version 3.10, right? So we can start with the Python thread learning paths, right? So first questions, it comes, what is thread? So thread is a separate flow of execution, and this means that your program will have two things at once. But for most Python 3 implementations, the different threads do not actually execute at the same time. They merely appear, right? It's clear, right? So it's tempting to think of threading as having two or more different processors running on your program. So each one doing an independent task at the same time. So that is almost right. The threads may be running on different processors. They will only be running one at a time, right? So getting some multiple tasks running so simultaneously requires a non-standard implementations of the Python. Writing some of your code in different languages or using multi-processing, which comes with some extra because of the way C Python implementation of the Python works. Threading may not speed up all tasks. This is due to the interactions with the GIL. So that essentially limit one Python thread to run at a time. So we will see global interpreter lock in next slide, right? So tasks that spend much of their time waiting for external events are generally good candidates for threading. Problems that require heavy CPU computations and spending little time waiting for external events might not foster at all, right? So this is true that we will write the code in Python and running on the standard C Python implementation. So if our threads are written in C, so they have the ability to release the global interpreter log and run concurrently, which we will see in next slide. So you have to aware about, like, if you are running on a different Python implementations, so check with the like documentations too and how it handles threads, right? So you can go to the documentations of the thread that will be helping you more. If you are running standard Python implementations, so writing in only Python and have a CPU bound problem, so you should check out the multiprocessing module instead. So architecting your program to use threading can also provide gains in design clarity. So most of the examples I will cover here, and you will learn about this session and going to run faster because they are using threads. So using threads in them helps to make the design cleaner and easier to design. Right. So now here we got the session of basics theory of the threads. Now we will move starting a thread. Start a separate thread and you can create a thread instance and you that then tell it to dot start method. Start a separate methods to create the thread instance. So import logging first, right? Here you can see import threading and import time. So these are the basically inbuilt libraries and where we have to import. So I am defining a functions, thread functions name is a parameters, right? Logging dot info, thread percentage is starting name, time dot sleep. So it will be sleeping 2 seconds. Logging dot info, threads finishing. So at last I am giving if name is equal to main methods. I am calling the format and logging dot right. So here I think it is clear to everyone. We have seen also our minute seconds in previous session. So logging dot info main before creating thread and here x is equal to threading dot thread. It is calling the methods and logging the informations before an thread and wait for the right and logging dot info main alt. Right. So if you look around the logging statements, so you can see that main section is creating and starting the thread. Equal to threading dot thread, target is equal to thread, right? Target is equal to thread functions, right? So x dot start will be starting every thread when you creating the thread. So you pass it a functions and list containing the argument to add functions. In this case, you are telling the thread run thread functions and to pass it one as an argument. So in this session, yeah, you will use sequential integers as name of threads. So there is a threading dot get item which returns a unique for each thread. But these are usually neither short not easily readable. Thread functions basically itself does not do much. It simply logs some messages with a simple time dot sleep in between, right? You run this program as it is with line 20 with line commanded out and output will be like this, right? Here for creating the thread and before running the thread is starting and wait for the threads is all done and right. So these are the things. Now we are moving to slide daemon threads. Daemon threads in computer science, a daemon is a process that runs in the back, so that is called a daemon. Now the Python standard library provides threading in most of the primitives you will see in this sessions, and on this module nicely encapsulates threads, providing a clean interface to work with them. So what does it do? Python threading has a more specific view for them. The daemon thread will shut down immediately when the program exits. So one way to think about these definitions is to consider the daemon thread, a thread that runs in the background without worrying about shutting it down. Hopefully you are understanding this session. If you have any doubts, you can put your query at box. And if a program is running threads, that is dot that one, but then the program will wait for threads to complete before it terminates. And threads that are daemons, however, just killed whenever they are when the program is. It looks like a little more closely at the output of your our program, right? The last in the previous program in line, the running the program and about pause of the about 2 seconds, and after main has printed its all messages both the threads. So I think in this session you are learning a lot about demonstrate threads, multi-threading. So now we will see next thread, next slide, like joining a thread. Sorry, join a thread like daemon threads are handy, and but what about the when you want to wait for a thread to stop? So what about then you when you want to do that not execute? Working with many threads. So here I show you some demonstrations like the Jupyter notebook, open the Jupyter notebook. We can see some small programs and can see on the threads. So you will be learning a lot. So first, you have to import logging, right? First, you make it create a file here. It takes uh, 1 minute. Now, import logging, import threading. Now, after right now, I am creating define thread function. Here I am giving the parameters name login dot in thread and name. Now time dot sleep 2 seconds. So after that logging dot info thread as anything. So now I will call the name that is underscore main. Now format is equal is ASC name as percentage messages uh, down login dot basic config. Here I am formatting login dot info sorry basic config, and after that I am going to be format is equal to format. Now I level is equal to logging dot info and date format it fmt h m. I have covered in previous session. Now logging dot info. This is it before creating head. Now x is equal to threading as for function threading dot thread target is equal to thread functions args. It should be fine, right? Now let's start by do it. Have some logging dot and code running thread. Dot start logging dot info in page. Wait for the thread to minutes. Try this program, right? And logging dot info again I will write and in main all. Okay, so this is the thing that here I am using, and you just start your function x dot start, and you will find the log that. So you can look around the logging statements in this session, and you can see that the main section is created starting. Right? So in this session, we have seen the thread, how it works, right, and working with many threads, daemon threads. We will see the execution in next session. That's for the day. If you have any doubts, so please you carry on.